Next up, we have Zach Simone. Zach Simone is a great guy. He is... one of the great things about Zach is he is a community builder, right? And I think one of the things that we have learned since COVID is that communities, like development communities, they can't just be reliant on big events, because big events come and they go, right? Even without COVID, we saw that before, like events would run for some period of time, and for whatever reason, they wouldn't be sustainable and they'd go. No, the real community for our kinds of groups are in smaller community-run events like Cocoa Heads, which Zach is a huge proponent for over in Sydney. So please join me in welcoming Zach Simone.
Thank you. I've always wanted a James intro, so I can tick that one off the bucket list. But yeah, if you are in Sydney and Cocoa Heads happens to be on, definitely come and check us out. It's good fun. All right, so over the years, our phones have gotten better and better at being able to keep us up to date with important information. And there's times when you want this onslaught of information and times when you don't. So let's say you wanted to keep up to date with the scores in a live sports game. Well, until recently, the best way to do this would have been through push notifications, sending a new one each time there's an important update. And these are fine, but they're a little disruptive. And there's also widgets, and these get us most of the way there. But widgets are shown all the time, even when there isn't anything to see. And so there's got to be a better way, right? And that's where the topic of this talk comes into it. Live activities. But what is a live activity? Well, it's a bit of UI designed to show important information or status updates. They live outside of your app and are designed to offer glanceable information in a way that's currently and contextually relevant to the user using their iOS device. You can think of them a little bit like widgets, but for something more pressing or immediate. But importantly, and unlike widgets, they go away when they're not needed, so they don't clutter your device. And they've been a feature of iOS since iOS 16.1, first introduced as a way to make use of the space around the dynamic island. And that's the hardware space at the top of modern iPhones that houses the sensor and camera arrays. Live activities manage to make use of this space in a playful, creative, and very useful way. So since seeing them initially, I've been fascinated by live activities and I've really loved using them. There are a few really good ones out there. I'll call out a few now. So Uber have an excellent one. It's pretty good at showing you only the most relevant information. There's obviously a lot of information about your ride, but Uber is good in that while you're waiting for a driver, it'll show you what car you're expecting, what the license plate is, and then when you're in the car, it transitions to how long until you get to your destination. And Flighty is a flight tracking app, and it does a great job as well. And it's almost like they've managed to cram multiple live activities into one. So in the lead up to your flight, it'll show information about the departure time, the gate. As you get closer to takeoff, it'll show you, what seat you're in. During the flight, it'll show you progress, of course. And then once you've landed, it transitions to showing you information about where to collect your bags. So it kind of supports you through that whole flying journey. There's also ScoreCheck for keeping up with live AFL scores during a match, and then similarly CricBuzz for the same thing but for cricket scores. And so why are live activities so good for sport? Well, matches are time limited. They have a lot of regular updates. And if you're a sport fan, you'll know that following live is super important. And the reason that you're probably checking the score on your phone is because you're not watching the game. You might be out and about. And so having the scores available at a glance is a lot easier than having to unlock your iPhone, find the right app, maybe navigate a couple of screens deep just to see what the live score is. And so this talk is, we've just been over an introduction to live activities, and I'm going to walk you through adding live activities to a live scores app. So there's a bit to talk about. We will talk about the UI and handling all of the relevant states, and then managing the life cycle of a live activity. And that's the start, update, and how to end a live activity. So along the way, I'll share some tips and tricks. At the end, I'll leave you with some more resources that you might find useful if you find yourself implementing live activities. And by the end of the talk, I hope you have an appreciation for them and start thinking about possible use cases in your own apps. But what qualifies me to talk about live activities? Not that much. But earlier this year, I launched an app called Charged, which shows the availability of EV chargers on your lock screen. But probably more importantly, I've built the app that we're going to be using for this example today. It's not on the App Store or anything, but it's just an app I built for myself to show live rugby league scores, specifically NRL matches with live activities, since such a thing doesn't exist in any of the public apps as far as I know. So we'll start by talking about the UI. And the first time someone sees your live activity will likely be on the lock screen of their phone. Then they'll unlock it, and assuming they have a device with a dynamic island, they'll notice it attached to either side of the dynamic island. Or maybe just on one side of the island if there's another live activity running at the same time. People with an Apple Watch and running watchOS 11 or later will notice that live activity pop up on their watch as well. And by default, this just mimics the view that's shown on your iPhone, but you can even provide a custom view for this as a developer. I'll talk a bit more about that later. And starting this year, live activities will show in your car through CarPlay and also on your Mac, which is pretty cool. And how do they work? Well, they use a few frameworks that you might be familiar with. First up is SwiftUI, and this is what's used for all of the user interface. I'm going to assume everyone's familiar enough with SwiftUI. I'm not really going to talk about that side of things for this talk. ActivityKit, this is kind of the meat of all the live activity stuff. And this is where we manage the live activity, so we handle its life cycle. There's also a bit of WidgetKit in there. Live activities aren't widgets, but they are built on top of the widget system. So we'll touch a little bit on the WidgetKit side of things as well. And the first step to creating a live activity in your app is to define a data structure. And this data structure should contain everything needed to render the UI on the live activity. And you'll notice here that we've defined a couple of structs. There's an outer one conforming to activity attributes, and there's an inner one. It's a nested struct called content state. And these are both required to define any live activity. And you might be wondering, why is the data split between these two models? Well, we put our static or our unchanging properties in the attributes struct. And so in our case, this is anything that's not going to change throughout the duration of a match. So things like the match ID, the team names, the start date, the venue, that's all static information, and we don't need to worry about updating it once a live activity's begun. But then there's the content that will change. This is our dynamic data, and that goes inside of the nested content state struct. So again, in our case, this is things like the current score, the match progress, the state. This is all going to change many times throughout the duration of the live activity. And you might be wondering, where does all this code go? Well, live activities leverage WidgetKit. And so we add a live activity to our widget extension by adding or defining an activity configuration for it. So you'll notice that this type conforms to widget. And so it might look familiar if you've worked with widgets. We just use a different configuration for them. But if you don't have a widget extension in your app already, you'll need to create one. When you create a widget extension, you get the option of including a live activity template. And so if you tick that box, you'll get some generated code that looks a lot like what's on screen now. If you already have a widget target, you don't need to create anything new. You just need to create that new widget type and add it to your existing widget bundle, like there, in amongst your regular, say, home screen and lock screen iOS widgets. So we'll focus on this widget type for a second. And it's here where we get to define the UI for the live activity across the various states it can be presented in. And we do this by returning views from these couple of closures here. And notice how each one gets this context parameter. And it's through this property that our UI or our SwiftUI views can access the latest state of our data. And that's all provided through ActivityKit. It'll make sure that our UI is receiving the latest context available. And when I say our data, I'm just talking about those two structs that we defined earlier. So the attributes for the live activity, as well as the content state. And so in this top closure here, we need to return a view that's shown on the lock screen. And this is just like pretty much any old SwiftUI view. There's a few size limitations, like it can't be more than 160 points high and things like that, but for the most part, you'll fit plenty of content in there. But I want to look at how this is defined for a second, because this is also the view which can be shown when the live activity is presented in CarPlay or on the Apple Watch. And so it's here where we get the opportunity to branch our views and show something different depending on the activity family, which is how those two states are identified. So we can observe that activity family in the environment and return a view better suited to a smaller display. And then the last step to making sure that ActivityKit is using that smaller view is to set the supplemental activities family modifier on the configuration. And then that just indicates to the system that we do want to handle this with a custom view. And it will look great on the Apple Watch and in CarPlay. But of course, our live activity can also be presented in the dynamic island too. And to make that all work, we need to fill in this second closure here. This is a bit longer, so I'll put it on a separate slide. It's from here that we return different views for all of the possible states that the activity could be in when it's shown on the island. So I'll start with probably the most common. You've got the compact and minimal states. And these kind of correspond to what's on screen now. So the compact presentations will always appear together. You'll always get both the left and right side of the, or leading and trailing side of the island at the same time. And this happens when you're the only live activity that's being presented. If you're sharing the island, or if your app has two live activities presented at the same time, you'll only get half of the island, and then you get to draw a a separate minimal view. And this is a really small amount of space that you're given here. It's kind of the hardest state you'll have to design for your live activity, because you can't actually fit much useful information in such a small space. Okay, and what about this first closure here? Well, it's where we define the UI for our live activity when it's in an expanded state. And an expanded state is just when someone long presses on the live activity to get a little bit more information. And it's actually split into multiple view components. And you can return as many or as few of these as you like, and the system will stitch them together. But they allow you to better hug the dynamic island by having leading and trailing views that go kind of to the full height. But it also works fine if you choose to omit them. You'll just have to you just won't have as much space to work with. And so in all of these closures, again, just like before, we can return pretty much any SwiftUI view, but keep in mind the background's always going to be black for your live activity views, for your dynamic island views. So you probably don't want to go too crazy with any backgrounds or colors here. Text works really well, simple shapes and simple images as well. They'll all look best and fit the overall vibe of the live activity. Okay, so now we understand how and why our UI is presented, and we've got a data model that we're going to use to power it. So let's talk about how to actually get data into our live activity extension. And the first thing to do is we need to start a live activity. And this is all the code that you need to do that. I'll break it down. So we start by constructing each of those two data models that we defined before. So we've got our attributes and our content state. We just construct them based on the latest match information that we might have from our server. And then to actually start the live activity, we call this request method. And this exists on any activity type. We pass it the state, and that's it. It will appear on the lock screen. ActivityKit will be responsible for rendering the view, showing it with the latest state. And that's what it looks like in our app's case. Before we move on from starting, it's worth noting there's a few new request methods in iOS 26. This one's caught my attention. It allows you to schedule start a live activity. So until now, up to iOS 18, calling that request method will start an activity immediately, but now you can actually schedule these for the future. So you might have someone use your app and opt in to subscribe to all updates for a certain team or on all days of the week or something like that, and you can just go through and schedule your activities for the whole season, which is pretty cool. And what about updating it? Well, it's quite simple. Again, we construct a new content state. We don't need to construct the attributes again because we only do that once. And we pass it to our current activity by calling the update method. It is that simple. But for that reason, it's probably worth keeping a reference in your code to the activity once it's started. And if you forget to do that, you can access any current live activities through this activities array that exists on any kind of activity type. And it's probably worth checking if there's any active live activities, say when your app launches, so that you can restore things if you need to inside of the app. And so with our latest content update, you'll see that the UI has been redrawn and it shows our latest data. All going well so far. And how about ending it? Well, the match is finished. It's time to stop the live activity. We don't have any more updates. Again, this is a lot like doing the update. We construct our final content state. This is just, again, that content state struct, and we pass it through to the activity calling the end method. And note we get the option here of providing a dismissal policy. So by default, once an activity is ended, it'll be cleared from the lock screen after 4 hours. It's a pretty long amount of time. A user can swipe to dismiss manually, but if they don't, that 4-hour window applies. But there's also a few other options we can use. So you can choose to have it immediately cleared from the lock screen, or if that 4-hour window doesn't work, you can set a custom date as well. And so just like that, our live activity is in the ended state, still appearing on the lock screen for now. But note that once you've ended it, you can't update it anymore. So you do actually need to make sure that your data is as final as it's going to get before calling that end method. Okay, so that's start to end life cycle of a live activity that's locally managed. And it's all well and good, but some of you might have already started to realize the problem. This is all Swift code. This is all running from our main app bundle. And in order to run these actions and update the live activity, the app either has to be open or be receiving background app time, like background app refresh time, which I don't know about you, but I haven't managed to get background app refresh to run every few minutes consistently for an 80-minute window. So these update methods, they're good, but they're not going to work for our app where we need real-time information, real-time updates. So let's talk about controlling live activities from a server. And yeah, this is way more suited to our app. We need those frequent updates. So it's built on the back of the existing push notification system on iOS. And the advantages of this are that we can push the updates to the devices in real time to the live activity, as opposed to waiting for the live activity to update manually, say via that background app refresh, or even something like widgets, which act on like a pull basis, and you can't reliably control them either. APNS, Apple's push notification service, which is used for this, it exists, it's fast, it's designed to handle a lot of updates close together. We're talking small payloads, so it's not like computationally expensive to receive these. And if you already have infrastructure in place to send like regular push notifications, it's not going to be much of a stretch to support ActivityKit push notifications as well. And the way that this all works is it's based around tokens. So you'd probably be familiar with this if you've worked with regular push, but in case you haven't, the way that it works is our server sends updates to Apple's push notification service, or APNS, with messages that are then forwarded onto the target devices. And these devices are identified by tokens, which are provided to our app. And it's up to us to capture these and store them as we see fit. And so the two that you'll be working with for live activities are, the first one is push to start tokens. And as the name suggests, these are used to start live activities. And these are unique for each device, but also for each live activity type. So our app has one live activity type. We only get one of these tokens. But for an app that had 2 or 3, you'd get 2 or 3 different tokens. And then there's also update tokens. Apple calls them push tokens in the documentation, but I'm going to refer to them as update tokens because I think it's clearer. And these are used to update a unique live activity. And so every time you start a live activity, you get the option of accessing a new push token. And so it's only good for the lifetime of the individual live activity. And how do we capture a push token? Well, there's an async sequence available on an activity type, which code above just is what you need to do to subscribe to that. And from here, you should send it to your server associated with the current device, and we'll use it a bit later on. And just like regular push tokens or device tokens, capture these as early as you can in your app's lifecycle, and they do change frequently. So you've always got to be looking for the latest updates. Push tokens, I've kind of already mentioned these, but you can access them through a different async sequence that exists on an individual activity. Again, you want to send it to your server associating it with the current device as well as the current activity. Each activity has an ID and stuff, so you can map that accordingly. And this is available asynchronously once a live activity starts. So the phone will call this every time there's a new or updated token unique to that live activity. So it's best to keep that subscriber running as long as you can. And now it's time to put those tokens to use on our server. So we need to construct a payload which we're going to send to Apple's push service. And so at no point does our server send messages directly to the target device. It'll all go through APNS. And this payload would look familiar if you've worked with regular push notifications, but there are a few key differences. So the first is that you need to add push type.live activity to the end of the app's bundle ID in the topic header field. And you also should set the push type to live activity. And this kind of differentiates us from regular push notifications. I'll talk about the body of the request in a minute. There's a bit that goes in here, so that's on another slide. And we also need to add the device tokens here. So this is either the device token to start, push to start token, or the regular update token, depending on the type of request we're doing. And here's the body of the request. To start a live activity, it's a bit involved. It should look something like this. It's just a JSON payload, and there's a few things that are worth noting. So the first is you set a timestamp associated with the update, and this is just so the device can sort them if they're received out of order. You can also set a relevance score, which is interesting. It's really only relevant if your app is going to present multiple live activities simultaneously. And if that's the case, the one with the highest relevance score will appear first. So first on the lock screen, first in the dynamic island. So in our case, we might do something like any match that's currently live, we send a higher relevance score than something that's finished or upcoming. And so speaking of multiple live activities, there's currently a limit of 5 active ones per app. There's no point trying to start any beyond this point because they'll fail. That's just a system enforced limit. And because this is a event we're sending when we want to start a live activity, we need to set the event type to start. And then here's where we send through our data, which is actually going to power the live activity. So this content state should match the content state struct that we defined in our app and be decodable to the same type. And the same with this attributes payload here, which should match the attributes we've defined in live activity in our app. When starting a live activity, you also need to set the value of this alert type with a title and body here. This looks a lot like a regular push notification. The contents of this isn't necessarily displayed. It's not shown at all on an iPhone, but the presence of this alert will cause the receiving device to light up as though you received a notification, and this is just a requirement when starting a live activity. And then finally, we need to specify which live activity type we're starting, and we do this by filling in the activity type value here, and it just matches it should match the activity type identifier that's defined in your app's code. And so there's a bit more work involved there, but the end result is the same. The live activity started on our phone, and we haven't even had to open the app, so that's pretty cool. And so now the match has started, there's been some score updates. Let's talk about sending the payload to update this live activity. The first difference is we're going to send it to the update token rather than the start token. But the payload itself is a lot similar. So we send an update event, and then we only need to send through our content state. We don't need to worry about the attributes because we set them the first time. And like that, it's updated. The update appears on the lock screen. ActivityKit will handle this. So once it receives the update, it'll redraw all of your Swift UI views, and it means the next time someone looks at their phone, it's all up to date. It's pretty cool. And I've kind of been talking about these update methods as though they're separate, like you either do it on device or you do it from a server, but you can actually mix and match how you do it. It depends on the app you're building, what's most appropriate. But you could start one remotely and update it locally or vice versa, though it is worth noting that if you're going to start one on device and update it from a server later on, it's important to set the push type to token when you call that request method. So this is the code from before, just with the push type changed, and that'll ensure that the device generates and you receive an updated token. An update token to use. You're probably starting to catch on now. The ending is very similar to an update, so I won't spend too much time on it. We set the event type to end, send through our final content state, and then the live activity goes into that ended state. We also get the option of setting the dismissal date again, and it works very much the same. If we omit it, we'll get the 4-hour window. If we set it to a date in the past, it'll dismiss immediately, or otherwise we can set a date or a timestamp of our choosing here. And there you go, just like before, the ended live activity is still on our lock screen. And so something to note is that when a live activity is ended but not dismissed, kind of in that awkward state, it shows on the lock screen and in Notification Center, but it won't show in the dynamic island. So depending on the user experience you want for your app, that may or may not be relevant. In my case, I'd probably want to see the score about 15 minutes up to 15 minutes after a game ends. So I don't actually send the end event for a while still, just so that the score stays on the device front and center for a while. And so there is one more thing that I want to mention here before ending. And it's an even easier way to update live activities for many people simultaneously, and it's called broadcast push notifications. So I've already mentioned that remote live activity updates are built on the back of the push notification system, but push notifications are a one-to-one update system, meaning that if you need to send the same update to 100,000 devices, your server has to make 100,000 requests to Apple server, and then Apple server will forward that on to all of the target devices. It's a lot of work. And it's the same for live activity updates, or at least it was until iOS 18, which introduced the concept of broadcast push notifications. And these are used to update the same live activity for multiple people simultaneously with one request from our server to Apple servers. Now, interestingly, it's currently not available for regular notifications, just live activities, but the name is broadcast push notifications. So it wouldn't surprise me if in future years this branches out to be more than for just ActivityKit. But it's perfect for our app. We're not customizing the live activity for individual users. We are just sending the same old score updates to every person who's using it. And it's all based around the idea of channels. So to use broadcast push, we need to create a channel for each live activity that our app wants to create or wants to start. And we do this using Apple's channel management endpoints. You can have up to 10,000 of these active at a time, so quite a high limit. And so in our case, we create one for each match of the season. And then once the match is over and we're confident there's no more updates, we can safely delete that channel or make a request to Apple service to delete that channel. And then that frees up our limit for later use. Now, interestingly, you can use broadcast push notifications to update and end live activities, but you can't use them to start live activities. And so you need to do one of the existing methods that we've already looked at for that. It's actually probably a good candidate for the schedule start that you can do in the app, because then you can kind of skip the whole needing to start via a server and sending all those unique requests. So the code to subscribe to live activities on a channel, the code looks very similar to before. This is what we did in our app much earlier in the presentation, but we set the push type to channel and we pass it the channel ID. And that's kind of all you need to do to get that live activity listening on that channel. And then to do it remotely from a server, again, it's the same start event. We send it to that same start token. We just need to add the input push channel to the request here, and that'll let the device know to listen to all updates on that channel from that point forward. But it's the update and end methods that need to change on our server to support this. So the main differences here, well, we're still sending an update to APNS, that's the first thing, but the URL changes. This is the sandbox URL, but the prod one's pretty similar. It's a new URL though, and we add the bundle ID to the URL. We don't add it in the header like we did for regular updates, and then we need to set the channel ID as a header as well. And so that gives the device or the receiving device enough information to know to start that live activity and listen in on that channel. The end event, again, very similar to the previous one, except we set the event type to end. That's really the only difference. So that's it. That's all the technical stuff for live activities. Hopefully by now you have a pretty good understanding of the bunch of ways to control and update and end live activities. There's a bit there. But I did say I'd leave you with some resources. So I found these quite useful when implementing live activities. And the first is straight from Uber's engineering blog. And it's a write-up about how they went through the design process, they overcame some technical challenges, and all round it's a pretty good read for any iOS developer, not just anyone who's implementing live activities. It's just interesting to hear how they had a problem and solved it. There's a pretty good blog post from iOS developer Christian Seelig that talks a lot about what you need to do on your server to get remote live activities up and running. There's not that much other information out there about this, so this was a pretty good and useful resource. There's a WWDC video from 2023 titled Design Dynamic Live Activities, and I'd suggest watching it before attempting to design live activities, because it talks a lot about the subtleties of designing for the constrained space, and also features a bunch of really good UI examples and playful animations of apps that make use of the dynamic island. And then finally, a couple of quick tips in case you find yourself building a live activity. The first is that really Apple's documentation for live activities is excellent. There's like 3 or 4 web pages that you could read start to end, and you'd probably be 80–90% of the way there, and then you just need to look for some other resources for fill in the blanks. But it is really good and really thorough. And then finally, if you weren't aware of the push notification testing console, I'd suggest checking that out. It's a good way to help debug any problems with both regular push notifications, but also live activity updates. It'll tell you if your payload's wrong, if it's missing a key, or maybe everything about payload's correct, but you're sending it to the wrong device token or something. It'll tell you if the update ever gets delivered to the target device. Just a really useful tool to have in your back pocket when working with this kind of stuff. So truly, that's the end this time. Thanks for listening. And, if you have any questions, if there's time.
Quick question from me, Zach. So in the screenshots you showed with the game scores, the Dragons always seem to have the highest score. Just wondering, does it also work with realistic game scores?
All real screenshots, I think.
Right, any proper questions? Louis.
Does the leading and trailing switch around in like Arabic languages? It's a really random question.
Yeah, I would assume so. I haven't actually tried. I would assume so. Given they're called leading and trailing, that would make sense. Yeah.
Yeah. Okay.
But I haven't tried that.
Okay. Because that's all good. Thanks.
Yeah.
TC just looked at you as if to say, "That is a really good question."
It is.
Yes.
So thanks for the talk. In terms of sport's always changing. So with start times and stuff like that, when do you sort of decide to promote something from a static data to a live data? So I've been to many football matches that said to start at 5 o'clock and end up starting at 7:30 due to rain delays.
Yeah, that's a good question.
Or flights for that matter, like boarding times.
Yeah, so I think it really depends on what you're working with. So something like flights, the way that Flighty works, and I can speak to this, is that as long as if it's scheduled to start within 3 hours, you'll get the notification on your screen, and then even if it's delayed, it'll just remain until you get on your flight. I assume sports should be treated the same. I actually haven't run into that scenario in this app where it's scheduled to start at a certain time and it comes later. My code at the moment on the server is basically like if it's scheduled within 30 minutes, then put it on the lock screen, and then the updates start 30 minutes later, and it would just kind of stay around until the match actually starts. It's worth noting there's an 8-hour time limit for any live activity, and so you can't work around that, but you kind of can if you quickly end and start a new live activity. And so I haven't had to deal with that when we're talking like 2 or 3 hour matches, but for the flight situation, they've got a good system that you don't even notice it, but it does delete the live activity and start a new one after 8 hours, and I've never noticed any issues there. So, yeah.
Last question.
I presume it's not a problem in the large dynamic version if you have dynamic text, as long as you allow for that, and you might have to clip the font size so it fits within the 160. But I presume you're doomed in the really compact versions of there's only a tiny amount of space. You're stuck with the biggest font that'll fit the relevant data.
Yeah, the second part, I think so. You are stuck, but I think, don't quote me, I think the 160 gets bigger if your font size is bigger. I don't know exactly how it scales, but I'm pretty sure that's how that works. You probably can't fit as much stuff, but you get a little bit more room. Yeah. Cool.
Thank you, Zach. Unfortunately, we've got to stop there because our next speaker has a little bit of setup work to do. So please, another round of applause, Zach.
Thank you.